All right, here's a good question on stoichiometry. So what volume of hydrogen gas measured at STP? So this is volume equals something. And STP, so temperature 273.15 and pressure is 100 kilopascals. Reaction between 2.84 grams of this, so mass is 2.84 grams, and they have HCl, they have a volume of 50 milliliters. I'll convert that to liters, and the concentration is 1.50 moles per liter. So it looks like they gave us too much information. So they gave us everything we need to know to find moles on magnesium and everything I need to find moles of hydrochloric acid. So I'm going to have to use a limiting reactant, figure out which one's limiting, and then do stoichiometry with that. Let's balance the equation before we get going too far. I think I need to put a 2 there, and I think a 1 there and there. I think that balances it. Okay, so let's first find our limiting reactant. So to do that, I find moles of each one of these reactants. So the moles of magnesium will be 2.84 grams divided by 24.31. So that's just the mass over molar mass. Calculator. Okay, that comes out to 0.1168 2, etc. moles. Okay, now I'm going to do this slightly different. Let's see how many moles of hydrochloric acid I would need. So I have this many moles of magnesium. So if I take that number, 11682 moles of magnesium, and multiply it by the mole ratio, so 2 moles HCl react with 1 mole of magnesium. Let's see what that comes out to. So that's 0.2336. So this is how many moles of HCl I need to react with all the hydrochloric acid. Not the hydrochloric acid, all of the magnesium. Okay, so now let's actually figure out how much magnesium we have. So this is my concentration and volume. So C equals N over V, and I want to solve for N. So N is equal to C times V. So concentration 1.50 moles per liter, and the volume 0.0500 liters. So if, when I multiply all that out, I'll get 1.5 times 0.05. That comes out to 0.075 moles of HCl. Okay, now I look up here, and it says that's how many moles of magnesium I need to use up all... No, that's how many moles of hydrochloric acid I need in order to use up all of this magnesium. But all I have is this many moles of hydrochloric acid, so I don't have enough. Therefore, HCl is my limiting reactant. Okay, so since it's my limiting reactant, then I'm going to do my river. So solid, liquid, gas, and I'm starting at liquid because this here is my limiting reactant. So I'm starting here, going to moles, and then they want to know a gas. So I'm doing that. So step 1 is this, and step 1 is actually done already, right there. I've converted that to moles. Now let's do step 2. And I want to get now moles of hydrogen. So I have 0.075 moles of HCl, I'll multiply that by 1 mole of hydrogen is produced for every 2 moles of HCl that gets used up. So I need to take that number and divide it by 2. So it'll give me 0.0375 moles of hydrogen gas. So then my last step will be to take those moles and the temperature and the pressure from up above here, and from those find the volume of hydrogen gas. Okay, so my formula is PV equals nRT. I'm looking for volume, so it's nRT over P. Moles, I just figured those out. Universal gas constant. Temperature was STP, so 273.15. And the pressure is at STP, so it's 100.0 kilopascals. So those cancel out, the kelvins cancel out, the moles cancel out. I'm left with liters. So I need to take that number then and multiply by 8.314 times 273.15 and divide that by 100. Okay, so the volume comes out to 0.851613 liters. I look up and it looks like 3 sig figs everywhere. So it'll be 0.852 liters. That's how much hydrogen will be produced if you have 2.84 grams of magnesium and if you have this concentration of hydrochloric acid.